GPU infrastructure is one of the fastest growing cost centers in modern engineering organizations, but it's also one of the hardest to understand and to optimize. The result is that most organizations are wasting a lot of their GPU spend without even necessarily knowing about it. I'd like to show you how Sedai is addressing the issue with our new GPU optimization capabilities. Let's start with one of the most common and costly patterns that we see: GPUs that are requested but not actually being used. This actually happens a lot, right? A developer kicks off a job, gets pulled onto something else, and the pod keeps running with a GPU allocated, but it's doing nothing. You're paying for it, but nothing is actually using it. Here's an example. For this workload, we've detected that a GPU has been requested, but utilization is effectively zero. So Sedai recommends removing it. With one click, Sedai will execute that action safely, running through a full set of safety checks before touching anything in production. The second pattern is a little more subtle, but it's also very costly. Even when a GPU is being used, many workloads can only utilize, say, 35 or 40% of a full GPU. The rest is wasted because Kubernetes has no native way to share a GPU between workloads. Sedai solves this using MIG, or multi-instance GPU. MIG allows a single physical GPU to be partitioned into isolated instances, each with its own dedicated memory and compute. So when Sedai detects a workload that doesn't need a full GPU, it recommends a MIG partition sized appropriately for that workload. So here you can see a recommendation to move from a full GPU to a specific MIG slice. If we click on execute, again, Copilot will take care of this for us. Let me pull up an example of a MIG-related action that's already been executed. You'll see that Sedai takes all of the steps needed to make this change, including safety checks, checking prerequisites, creating the resource claim, and finally updating the workload. This is all work that would otherwise fall on your platform or your ML infrastructure team, requiring deep knowledge of NVIDIA's toolchain, Kubernetes internals, and your specific cluster configuration. Sedai handles all of that for you with a full audit trail of exactly what we did and why. Beyond individual workloads, Sedai also looks at your GPU node pools as a whole. So here in the GPU node pool optimization view, Sedai identifies nodes where GPU devices are completely idle, meaning that there's an opportunity to consolidate workloads and reclaim entire nodes. This is sort of the GPU equivalent of cluster compaction. And again, the savings can be really significant when you're talking about GPU node hourly rates. Across all three of these capabilities, idle GPU elimination, MIG right sizing, and node pool optimization, Sedai automates what would otherwise be a really tedious manual process requiring a deep level of expertise. If your team is running GPU workloads and you're not sure where that spend is going or how to really optimize it, we would love to show you what Sedai can do in your environment. So book a demo with us at sedai.io.